All right, everybody. Welcome to our conceptual model for learning data analysis. I'm William O'Bannon of StatsWhisper. Very happy to bring you this presentation. This presentation is actually probably the biggest key to what we'll be learning over these several weeks. So I just want you to please stick with me, because we have a lot to review, a lot of good stuff though. So I have found perhaps the best way to relate what you're learning is related to a process that you already know. Right now, this isn't a religious show, but there was a small excerpt from the Bible that actually illustrated this pretty well. There was a story that Jesus came upon two fishermen named Simon and Peter, and he wanted them as his apostles and to help, find participants for Christianity. But when he went up to Simon and Peter, pardon me, he didn't say, could you help me recruit people into Christianity? He said, come with me and I will make you fishers of men. And they automatically understood exactly what he was talking about because they were fishermen, right? You meet people, you put out a little bait, you reel them in, right? They understood right away. He related something they already knew to something he was trying to communicate to them. Now for data analysis, we're going to do the same thing, but we're going to parallel it with the process of dating analysis. Now, the thing with dating is it's just so engaging for people usually. Even in this, I make up the dating scenario, and people still get curious about who's dating who and how the relationships are working. And I say, well, I'm making it up. And they say, well, we're still curious, right? So it's just something very engaging about that process. So I find that it's generally a good one to use. Now, one of the best tools for really understanding variables is to view them, well, as people, because people are dynamic and people have their own characteristics and their own types of behavior toward other people, right? And so do variables. Now, while most people realize this about people, they don't really realize it about variables. So sometimes it's a big help to generalize from one to the other. So perceiving variables as people, personalize, right? So make it personal to you. So see variables as relatable, right? You find like a person. Sometimes you can relate to other people, you understand them. And so to truly understand the variables, you must relate to their characteristics and behaviors the same way as you might relate to another person's characteristics and behaviors, right? The less that variables are just words on a piece of paper or on a computer screen, and the more they are actual living things with characteristics and behaviors, the more you'll understand them and understand the relationships between them, which is it's to think like a researcher and think like a data analyst. That's how it is. You see those variables as having their own characteristics and behaviors. So the dynamic characteristics of variables and people. If I were to tell you I had a client and they were depressed, even if that's all I told you, you would have an image in your head, right, about what the person looked like, what they sounded like, and also about their characteristics. You'd say, well, if they're depressed, they probably lack vigor. They probably have some lethargy. And they probably have a change in appetite, right? Either eating a lot more, eating a lot less, right? So that would be the person in your mind. Now, if we were doing a data analysis and we had an SPSS database, right, the software program we do the analysis on many times, and I said there's a variable in that database called depression, right? You need to think about what are the qualities of that depression. Normally the depression in the database is a bunch of questions added up, and probably some of them would have to do with changes in eating and lethargy, right? but you have to think of it as a person, because it's going to have the same characteristics as that person with quality, right? So yeah, think about it. Give it a good deal of thought. How if depression, the variable, was a person, how would it look? How would it sound, right? And then also the next step, and perhaps even more importantly, how would it behave toward other variables, right? Because in the database, we have to think about our variables, but then the whole reason for analysis is we have to think about how the variables we're looking at are going to impact the other variables around, right? So a good way to do that is to think about, right, how two people with the same qualities as the two variables might react to one another. So as an example, we have here the relationship behaviors. If we had a very depressed person and they met a very happy person, what would the interaction go like? Well, it might be a negative reaction, right? That the sad person might say, well, I'm not ready to be around somebody in such an up mood right now. I'm kind of sad. And the sad person might say, and the happy person, pardon me, might say, well, I have this up mood going on, and I don't really want to be sad, seeing someone being sad. So they might go in two opposite directions after a negative reaction to one another. Now, how does this relate to variables? If you had a database and you had one variable called depression, and it was measured on a scale of 1 to 5, and you had another variable called happiness, and it was measured on a scale of 1 to 5, as the scores for depression go up, 1, 2, 3, 4, 5, what would we expect the scores for happiness to do? They would go in the opposite direction, as in the higher the scores for depression, the lower the scores for happiness. So if someone reports a 5 for depression, that same person will probably report, the opposite end of the scale for happiness, right? So they have a negative relationship, meaning as one goes up, the other goes down. So they have a negative relationship, just like the negative interaction, and then they go in opposite directions, just like the two people might do if you had two people of the same qualities. Now, this is probably a little far out for people, but as we go and we look at variables and how they react to one another, really getting personal with these variables and examining them and giving them a life of their own helps understand their characteristics and their behavior toward other variables. And the better you can understand that, the better you will be at data analysis. So, meet and learn to treat the 3 types of variables, part 2. Now, if you were treating people, you'd have to know how to treat a whole lot of different kinds of people, because there's a whole lot of different kinds of people in the world. However, if we're talking structurally, there's only 3 types of variables we need to consider for this statistical analysis. The first one is a continuous variable, right? So if we're measuring depression on a score of 1 to 5, right, it goes 1, 2, 3, 4, 5, 5 meaning more depression. That's a continuous variable. Then the next structure is a categorical variable that has 2 categories. So that could be depression 2, however it might be, are you depressed? 2 categories, yes, no, right? That's a 2-category response. It's either yes or it's no. And it's measuring the same construct. It's the structure that's important, not the construct, meaning it's the fact that one's continuous and the other is categorical with 2 categories. Then the third type of structural variable that we need to keep in mind is having more than 3 or more categories. So that could be, is someone depressed? Yes, no, or maybe, right? So that would be 3 possible categorical responses, right? The responses are in categories, yes, no, or maybe, 3 categories, or 3 or more, so it could be, any number after that. So if you were a data doctor, right, and you know how to treat these 3 structural variables, you would have a complete practice. So that's why we're specifically looking at these three kinds of structural variables. The data analysis ends, meaning the final round of analysis, the multivariate round as we call it, it ends with a regression procedure. And here, for data doctors, we might call that a regression treatment, right? Now, the regression treatment at the end of the analysis is going to be different for each structural type of variable. For the continuous variable, we'll use linear regression. For the two-category variable, categorical with two categories, we'll use binary logistic regression. And for the categorical variable with three or more categories, we'll use multinomial logistic regression. Now there's one point that needs to be made very clear right away. It's that this course is learning the 6-step process of data analysis. Now you could just take one of those variables, structure, like the continuous or category, you could just take one of those and do an analysis of that variable, and you would have illustrated the 6-step process of data analysis, right, which is the point of this program. However, the trouble is that if you learn the 6-step process of data analysis with a continuous variable, and then you have to do a study that has a categorical variable, either no matter how many categories, then you won't have experience in applying that 6-step process to an analysis that ends up, with the different regression models, which would be a problem. So in this program, we're going to do 3 data analysis studies. Each one is going to use one of those structured variables. So no matter what you encounter after this program, you'll be able to do the analysis called for. Okay? There we go. So part 3, tools for learning data analysis, job experience. Now, studies show that lecture and classroom teaching have I think the lowest rate of retention. Right after the lecture, only 30% of what was learned is retained, and then a week later after that, it's a lot lower. So what we're going to do is an on-the-job experience. So we're going to complete the 3 data analysis projects in an applied, experiential, on-the-job way. That'll also make it kind of more fun and exciting. Now, the great thing about this is you're simulating on-the-job experience. So if you ever need to do these studies, right, you can see point 3, the templates, right? So if you actually do need to do these studies, you have a map of how you would follow the studies on the job, so you can actually do the studies because you've experienced doing them, and you also have it mapped out in these materials. So these will be templates. If you have to do your own study, there'll be templates where you can just plug in your own variables for any future studies you have. Right, but don't forget, we wanted to use a parallel process, right? Our dating process, right? So also you're going to have a second job where you have to complete 3 data analysis projects, right? So you're going to create 3 projects matching up daters, and that the process is very, very similar. So you'll see 6 here. If you can identify with one, then you can identify with the other. And like I said, most people can identify with dating, thereby eventually you'll be able to identify with the data analysis. So the goal of the data analysis in our case is to identify which independent variable has the strongest relationship to the dependent variable. And we're going to apply the 6-step process of data analysis to answer this question for each of our studies. Now, part 4, your job training. So, of course, you can't really have a job without job training, right? The secret is this job training is the foundational knowledge you need to have to do a data analysis project, and also a parallel data analysis project. I like to call it 8 simple facts for doing your data analysis, which is my homage to the 8 simple facts for dating your teenage daughter show. Okay, so a good way to remember that for those that know that show. So to do your data analysis, you need to know these 8 simple must-know facts. And it's must-know in quotations, and I'm the one saying it, so I'm quoting myself. All right, so the first thing you need to know is the entire 6-step process of data analysis prior to beginning the analysis, right? Like it says in the 7 Habits of Highly Effective People, to always start with the end in mind. And that's very, very good advice for what we're doing here. So we want to know what we're going to be doing at each stage and where we're going. So let's take this, the process of data analysis compared to the process of data analysis. So in terms of data analysis, let's take the eHarmony as an example. So what's the first thing when people want to employ eHarmony to do an analysis of themselves, right? So they're doing a data analysis of themselves. They're saying, who do I have the strongest relationship with in this eHarmony pool, right? So I can go out on a date, right? So they're looking for their strongest relationship so they could go out on a date. In data analysis, we want to find that strongest relationship between the independent and dependent variable, because if our dependent variable, say, is depression, we want to know what has the strongest relationship with depression so we could help cure people's depression. It might even be dating, so maybe they should be merged at some point. But that's for a future course. So the first thing you do when you go on eHarmony, right, the process of data analysis is you go on your computer and you enter your data in the eHarmony database. Say my name is so-and-so and I'm this age and I'm looking for this kind of person, and so on and so on. When you do a data analysis, pardon me, the first thing you do is you take the surveys completed by the study participants, right? So it's depression, they say how they answered their depression items, and they have their demographics, right? So you enter that into a software program on a computer such as SPSS. So in step 1 for both, you're taking information and you're putting it into a computer software database. Then for number 2, for eHarmony, right, the dating, they're going to want to check data integrity. So before you have a chance to meet anybody on their site, they're going to want to review you and make sure you're what? You're appropriate for dating analysis, appropriate for data analysis, right? They want to make sure that you have integrity, that you'll treat people properly, that there won't be any horrible negative situations, right? That's probably their biggest concern. Now the same thing with data analysis is that you're checking the integrity of the data to make sure the data are appropriate for analysis. For example, what if you're looking at education and depression and half the people didn't report their education level? Well, then the data might not be appropriate for analysis because so many of a key variable is missing. Also, for example, some of the assumptions of statistical tests say that there has to be a normal distribution of scores for a continuous variable, right? So if depression is 1 to 5, you want people that answered 1, that answered 2, that answered 3, that answered all the way up to 5. But what if everyone in your sample reported, a 5? Right? So if everyone in the sample reported a 5, you can't look at what affects depression because everyone's depressed. There's no non-depressed people to compare them to, right? So that data might not be appropriate for analysis. These are the two biggest steps in both processes, I would say. Step 3, if you're in your dating analysis, right after you enter your information and you get cleared as having integrity, and what's the next thing you do is you create a profile of yourself and you put it on the eHarmony site. Right? So it's a profile presenting what? Your characteristics, or whoever fills it out, the characteristics of one dater, right? You like moon that walks in the beach, and the characteristics of one dater. This is the same for data analysis at step 3, where you're generally expressing the characteristics of one variable. So if the variable was, say, gender was the variable, you would say gender is the variable, and 70%, you would describe it, 70% of the gender are males and 30% of gender are females. You might say, for depression, you might say depression is one variable and its characteristics are that the average score was 3.5, right? And the highest and lowest scores was 1 and 5, right? So you're just describing the characteristics of one variable the same way in a profile. You're describing the characteristics of one dater. Now, for step 4, right, in the data analysis, after you put out your profiles, typically, I believe, you get a slew of people that are interested in you. So you get 50 responses to your profile, and it's 50 people who all say, I'll go out with you. I'm not really sure how it works, but they all say, I'll go out with you, or I'll talk to you about going out with you. That sounds more reasonable. So what do you do there in step 4, the first round of analysis? You try to determine who you have a significant relationship with, right? So you look at them, you look at you say, I might have a significant relationship with this person and that person. So out of 50, maybe you identify 10 that you have a significant relationship with. And then you carry them forward to step 5, which is a final analysis round, where you say, of these 10 that I have a significant relationship with, who do I think I have the strongest relationship with? And then you have your answer, your strongest relationship, and you go out on a date. Then you could have your write-up and report, which could be one of those commercials where people report being happy and set up on eHarmony. So for step 4 in data analysis, right, what you're doing is you're taking all the independent variables, right? So if you're looking at depression, you look at education and gender and all these predictors of depression, and you're saying of all the independent variables, which has a significant relationship with the dependent variable, right? So which factor out of a bunch predicts, say, depression? And the ones that have a significant relationship, right, the ones that are statistically significantly related to depression, you take the significant ones and you carry them forward, just like you just find the significant relationships and carry them forward into the final analysis round, and that's where you employ the regression we discussed, and then the regression will tell you, out of all these significant relationships, which one has the strongest relationship to the dependent variable. So in both instances, you're identifying those significant relationships, carrying them forward to the next round, and of the significant relationships, you're determining which one has the strongest relationship to the dependent variable, or to you, the dater, or who the central dater is. And then for the data analysis, you have an extensive write-up and report to do. Must-know fact number 2. You must be able to identify the independent variable and dependent variable in data analysis, which is the focal point. Now this is the very foundation of data analysis, but that also warrants why it should be mentioned. So we have the study variables on the left here before they're ascribed as the independent or dependent variable. So you have happiness and many bills monthly and education level and your level of humor and aloofness. Now when you think about it, any one of those, right? So the dependent variable is our focal variable of study, the one we're interested in, the one we want to explain. When you think about it, any of the ones on the left could be the dependent variable, right? Any of them would be a very interesting topic to study. So selecting the independent variable is largely conceptual, right? So here we wanted to look and see if the independent variable happiness, right, is predicted by independent variable 1 having many bills monthly, 2 education level, 3 humor, 4 aloofness, right? So the very first step is out of the pool of variables specifying that focal dependent variable. Likewise, in dating analysis, right, we have independent suitors and a dependent client, right? So we want to keep these as parallel as possible, right? So we want to say who's the focal point. So we call them a dependent client because they're depending on you, the data analyst, to select the proper suitor for them to go out with, right? We call the suitors independent suitors because they're not actually clients. They're just people that needed dates, so they sent in their information. So your boss said, well, they're independent of our agency, but they're suitors, so we call them independent suitors. And the client is our client. They're depending on you, so they're the dependent client, right? So here we go. So if we had a pool of daters on the left, right? Terry, George, they're all unisex names. So you can't predict which is the dependent client. So if we have our pool of data, so out of all of them, you have to specify one as being the focal point. Like in the our last analysis with the computer dating, you were the focal point, like you were the data. This is more like, someone comes to you and they want you to set them up, and you have to say, okay, this is my dependent client who's depending on me, and these are the independent suitors who sent in their information. Who do they have the strongest relationship with so I can send them out on a date? Now again, you must know fact number 4, you have to be able to classify the variables as categorical or a continuous variable type. Now in classroom learning, many times you'll hear the terms nominal, ordinal, interval, and ratio, which is very appropriate and good. But once you leave class, variables are often referred to in research, as either categorical or continuous, right? So the categorical variables are the nominal or ordinal. So nominal is when it's answered in a category, right? But it can't be ranked. So an example is gender, right? So it's either male or female categorically, and it can't be ranked. One can't be said to be better than another. Second, we have ordinal, which is categorical, but it can be ranked. So if I say, what kind of mood are you in? You could say fair, good, great, right? So they could be ranked. But the key is, though, also, is that there's not equal spacing in between rankings. So we wouldn't expect that there's the same distance in between the ranking of fair to good as good to great, right? That's all kind of a conceptual ranking. Now, the continuous variables are the interval and ratio level variables. Now, these variables do have the same distance in between the rankings. Like, so if we're looking at interval and it's rank ordered and we're looking at IQ scores, there's the same distance between 80 and 90 as there is between 90 and 100, right? The difference between interval and ratio is interval does not have a true zero, So if there was a 0 on the IQ test, which there's not, but if there were, it would mean a complete lack of any, IQ whatsoever, right? There's no true 0. Now, ratio is rank ordered in the same way, but there is a true 0. So if we're talking about age, right, the moment of birth is 0, right? So there's a true 0 to age. And just like interval, from then on, it's ranked, and there's equal spaces in between measurements, 10 to 20, 20 to 30, that convey the same thing. Now, must know fact number 5. You must be able to classify daters as being of a categorical or continuous emotional type. So here we go again, generalizing between the variables and people's characteristics, right? So a variable can be yes, no. Now, I believe most of us have known people that have a yes, no sort of personality. And since dating has to do a lot with emotions, we're looking at emotional type. So a continuous emotional type would be somebody with a wide range of emotions. So that would be somebody that, just like they can either be extremely happy or extremely not happy or any gradation in between, right? They have a real wide range of emotions. Right? It's this, just like a continuous variable goes up and it goes down, and there's a greater presence and a lesser presence of a construct. Right? So number 2, categorical. So that would be someone that just feels one way or the other, just like the categorical variables, yes or no. If they're happy, they're either happy yes or they're happy no, and there's no in between, right? Or you could have a 3 categorical where they're either happy or they're unhappy or they're just sort of neither, right? So what we're trying to do here is illustrate, the type structure of variables through the emotional structure of people, right? So it's easier to personalize and understand those variables. So must know fact number 6. This is an important one. So we have our 3 studies. Now to complete those 3 studies, how many statistical tests do we need? Do we need 1 or 2 or 200 or 24? How many do we need? So there's only a pool of 8 statistical tests that we'll actually need to fully complete any of these 3 data analysis studies. And typically we're going to use just say 4 or 5 of the 8 in doing the data analysis. So you could see the number of actual statistical tests you need to use and employ is not many, right? It's more the conceptual, like learning how to actually use them the right way, that's so key. So the 8 statistical tests, right? So we'll say that there's 3 levels of analysis, and this relates to our whole profiles and then the first round of analysis and final analysis. That's what these 3 steps are. But 3 levels of analysis: uni, where we look at univariate or unidata, uni meaning 1. That's where we're looking at the one data or variable at a time, right? That's like the profiles. Then the second one is bi meaning 2. That means we're looking at the relationship between 2 variables, bivariate, or 2 datas, right? And that's at that second round, right? That's the first round of analysis. And then the next one is the multivariate or multi-data. That's where you're considering all of them at the same time, all the significant ones at the same time, to find that strongest relationship, right? So those are the 3 levels of analysis. Now, the 8 tests are distributed over these 3 levels of analysis. So the univariate, right, is frequencies, and then the bivariate, you have 4 tests there: the t-test, ANOVA, chi-square, and correlation. And the multivariate, you have the linear binary and multinomial regression that we mentioned earlier, right? So those are the tests you need to know to do your full statistical testing. So it's not that many. So selecting the correct statistical test is based on simple rules that consider if variables or daters are of a continuous or categorical types. Right? So we know the tests. Now we have to know which to use in what instance. And that's done through considering the structures of the variables or daters. So the univariate level, right, for the data analysis, all of them get univariate tests, whether they're categorical or continuous. You do a frequencies. You can run frequencies. And for categorical variables, when you do a frequency, you can observe the n, which means the number of people in each category. So if gender is 30% female, you know, how many people is that? What's the n? Is it like 20 people, 30 people? And the percentage, right? So that's obviously 30% female. For the continuous variables, you would observe, say, the mean score, the average score. So if it's depression, what was the average score of depression, the standard deviation, the min-max, which means what was the highest score, the lowest score, right? So that's simple for univariate because you're doing the same frequency test. Now the bivariate, the one-on-one testing, that's a little more intricate, but you have the key right here to do it, so it's not terribly worrisome. So variable, you're going to have a variable A and B because it's bivariate, meaning two variables, so there's always going to be two, an A and a B. So if you have a categorical variable and it has two categories, and the variable you're comparing it with is continuous, categorical such as male, female, continuous such as depression, you do a t-test. Then if it was categorical with more than two categories, i.e. three or more, right, and you're comparing it to a continuous variable, maybe it's, you know, education level compared to depression or ANOVA, and then if both are continuous, say like age and depression, correlation, and then if both are categorical, say education and gender, right, you do a chi-square. We'll be repeating all this many times. This is just a little early exposure. And then at that multivariate level, you're just selecting one of these tests for the final round of analysis. If it's a categorical dependent variable, binary logistic regression. If it's a categorical variable with more than two categories, multinomial logistic. And as we said before, if it's a continuous dependent variable, you use linear regression, right? So the earlier you hear these terms, the better. We'll be repeating them over and over and over because they're the real building blocks of analysis. So just hearing them the first time, even if you don't remember them, is actually very important. Now, must know fact number 8. There are 3 essential dimensions of a relationship to consider. And this goes for both the daters and the variables. They're exactly the same. So the 3 essential dimensions of a relationship to consider: significance. Now, when we do tests in SPSS and we try to figure out the statistical significance, that's expressed as probability being less than 0.05. And when you do the test in the database, it tells you if the probability is less than 0.05. Very simple. So if you had to do, say, t-test or any of those tests, it'll tell you if the significance level is less than 0.05. All right, and that's our first consideration. That's the same consideration as if, say, if you had a friend that went out on a date, right? So the first thing people say is, what do you think of the person you went out with? And if they say, then you know it's not a significant relationship. And then what do you know? It's not worth asking anything else about that relationship. If there's no significance in that relationship, you don't even consider it with another person, right? You know, that's it. The same thing with statistical analysis. if you do a test and probability is greater than 0.05, that's the same thing as you just don't consider it anymore. So the first thing in both instances is that relationship significant? The second thing is the directionality of that relationship, right? Meaning, if it's a person, the directionality might be, do you like them or dislike them, right? So they say there's a thin line between love and hate, but if there's no emotion at all, that's the non-significance. So if there's significance, we want to know the directionality. So do you feel significantly toward the person? On a date, somebody might say, oh yes, I feel strongly about them, right? And then, well, what does that mean? Does that mean you really like them? You really don't like them? That's the next thing you want to know. So in statistics, there's a minus or no minus sign in most statistical tests that'll tell you if it's a negative or positive relationship. So the next thing you want to know in both instances, is there a negative or positive relationship between the variables or people? And the third dimension of a relationship you need to consider is magnitude, right? So in a date, I like them. Somebody might say, yeah, I like the person, and then often they'll say, but do you like them, right? That's more of a measure of magnitude. That means you can like them, but that doesn't mean if it's just on the wire between liking them or not liking them, or if they really feel passionately. Right? It's a big difference. That's magnitude of the relationship. In statistics, the magnitude is conveyed often by the effect size. So if we hear like a study and it says eating fruit, you're 5 times more likely, to be happy. That's a relationship of magnitude, that 5 times more likely. Because if we said eating fruit, you're 10 times more likely to be happy, well, that's a relationship of greater magnitude, right? So, and if we say eating fruit, you're 2 times more likely to be happy, right? All of those reflect different magnitudes between the relationships, right? So that's our third consideration for relationships. So in any relationship, be it between people or variables, we want to know, is the relationship significant? If it is, what's the directionality? Is it positive or negative? And then lastly, we want to know the effect size. So if it's positive or negative, just how positive or negative is it, right? What's that effect?